In this chapter we will find about the BJT amplifier working, and this thing will be use the Bose gate analysis on a particular circuit. Now open the circuit left in a blank schematic. Now we're gonna have draw amplifier consisting of the transistor. So open the a blank schematic, enter the circuit as we are going to add the libraries and the components, connect all those components all together. Now you have to use the source of 1 volt AC and a 10 volt DC. So we have VDC, VAC of 1 volt AC. Select the transistor Q2 and 222 from the eval register. You will find at the analog and add the capacitors C2 from the analog. We need the parameter param and the breakout R break. Name all the resistors. R4 is the 1K R break. Use the net alias output. So that's the circuit of an transistor, which is at the base given with the 1 volt AC supply, and the 10 volt is the bias circuit, and output is taken between the emitter and the collector. And the parameter in the design cache, in the special, you will find param as a parameter. Over here the global parameter is the R val and the resistance. Add a euro. or make edit the model for the breakout register like 720 star R well. So whatever value will be multiplied by 720. The global value will be the R well, and it will be multiplied by 720 for particular R4. Edit the model break to RB mode. So this will create a RB mode register for our graph for a schematic. R1 equal to 1 and D def equals to 5%. Give a new simulation profile. We want to have an AC sweep. AC sweep will be from 90k. And frequency is 110k. Endpoint is 3. We are doing the Monte Carlo analysis for sensitivity. Output variable is the V out. The grade difference minimum value. We have to find the minimum value, mean 99k. The R4 we change to RB2. Resistance breakout. Run the simulation. Open the netlist. You will see that the worst case run is analysis shows this. Worst case analysis run is 15.169 at frequency of 100k. We want to keep this result into our considerations. Now what we're gonna do is now we're gonna have now simulation of a parametric analysis on that particular resistance value. So for 100k it was 15.16. So we're gonna give now a parametric sweep, a AC sweep with the parametric value, and have a linear sweep from 90k to 110k with we want 3 points. The frequency is, remember, 100k, and the value we got in our worst case is 15.169. so do parametric analysis for the global parameter R well, and give it a linear sweep from starting value of 8 to 0.8 to 1.2. V output. So this one is gives the result shows from the point 8 to 1.2, and once it crossed the 100, so we are interested to see the V output for up to like 100k. So we can clearly see this, that at 100 now type search level 15.169, because this in the search level select 15.169. so this will select that particular point which we are getting in the worst case analysis. So we are gonna cross check that point. Search forward level 15.169. so frequency was coming like 100k. So this will make us sure. Press OK. Yep. Press the mark label button. So this is the point, 15.169. Now let us see a point where we are misled by the worst case analysis. Change the model parameter to 1.1. Save the model and return to the capture mode. Now run the worst case analysis again. So you have to do Monte Carlo analysis. Output variable is the V volt. Procedure is just same, but we have changed the model parameter. In the mode setting, we are interested in to see the minimum value. Worst case direction is the low, so we are getting in the low direction. Now run the simulation. You will see the profile is generated. See that profile. In the worst case analysis, you will find that for all devices 79.641 at frequency of 90k. So this is the value of examine the following in your actual diagram. Run a new simulation. Y80, this is the point. Do as I'm doing over here. Place the marker. Search for the 0.169. press the marker symbol. So this was like 950k, and we are getting 79. And at the read the manual's last paragraph, to analyze what you are getting.